All right, we're going to factor by grouping. To factor by grouping, it's a couple phased process, but the first phase is you always cut your problem in half and you look for a left-hand GCF and you look for a right-hand GCF. And if I was in front of you, I would completely cover up the right-hand side to just get our eyes to focus on the left-hand side for GCF. And what you'll notice is that they both have an X in common. The numbers are not in common. So as I look and work, I see an X, and the lowest exponent that they have in common is 2, so it's X squared is my GCF. And if I divide properly, I will come up with a division here where the X squared and the X to the third reduce down to be 1, and there's a 4 there, so we need to have 4X to the 1 is what that would reduce down to be. And then we have the negative 5x squared, divide that by x squared, and the x squared part turns into a 1, but this is a minus 5. So now that I've finished the left-hand side, check that off, and then I basically mentally ignore the left-hand side completely, where I had scribbled out the right-hand side before. I'm basically covering up the left-hand side with my brain, my eyes, my hand, whatever it is, and I cover that up, where I'm just focusing on the right-hand side and any greatest common factor between them. And I don't have any variables in common this time. This time I just have a number part, a coefficient part in common, and 25 is what I'm seeing. Now it's got to be a positive 25. That sign is you have to have a sign here. There must be a sign, and the sign is positive 25. That is my common factor. So I'm going to divide each of these by 25, and 100 divided by 25 should be 4, and the x comes, so 4x, and the negative 25 divided by 25, the 125 divided by 25 should be negative 5. And now that I've divided correctly, I can factor one further step. So what I've done right here, this is one full step of factoring. This is the first step of the GCF process. And what always happens afterward is you've got to look, if it's done correctly, I'm going to make that a plus sign. It looks like a plus minus. If you've done things correctly, and if it's going to factor using the grouping method, is there will be a greatest common binomial factor here, and there is. Both of them have a 4x plus or minus 5. So I'm going to factor out a 4x minus 5 binomial, and what I will have left should just be these numbers in front. If you're dividing by this 4x minus 5, this part, anything divided by itself, is 1, and so the x minus 5 is left there. Or sorry, the x squared, that's what I meant to say, is left there. Dividing the second term by 4x minus 5, this all turns into a 1, and just the plus 25 will be left. Now, as we've done before, after factoring a binomial common factor, we would look for anything, especially in this second part, that perhaps might be factored further, and this time there is not. It's an x squared plus 25. That's the sum of squares. Later, we'll have some difference of squares opportunities and further factoring that can happen, but this is the fully factored problem, original polynomial cubic function that was done by grouping. Very common way to factor a cubic polynomial, if it factors. In our second example here of factoring by grouping, we're going to follow the same steps as before. The difference will be we're going to have to struggle perhaps with a negative in our GCF process on the right-hand side. So again, cut the problem in half, and then what we're looking for is a left GCF and a right GCF, one at a time. So for now, focus on the left-hand side, and we just see that there is an x squared in common. And so I open up some parentheses and do a division of each term. X to the third divided by x squared is a single x to the 1. And then that negative 7 divided by x squared divided by x squared is just a 1. So the negative 7 part comes down. So now I have checked off, I'm done with the left-hand GCF. Now I got to focus on the right-hand side. And so what students do here is they see the 14 and the 98, and they see that 14 goes into 98, but what they'll do is they'll just bring this negative sign down and not think about it. They'll just bring down a negative 14, and then they don't divide by negative 14. They just divide the 14, and we get x plus 7. And that's wrong. The reason why it's wrong is because you need to not just pull down the negative 14, you need to intentionally call it your GCF is negative 14. And if I'm intentional about that being my GCF, I need to divide each term by negative 14. And if I divide a negative 14x divided by a negative 14, I do get a positive x. So that part would have been okay. The issue is this positive 7 would have been wrong. I need to take this 98 and divide it by negative 14, and that should give me a negative 7 result. So making sure that we do have it working out so that these have the same binomial. See, had I had a plus sign there, I would have been stuck because these binomials must match for factoring by grouping to actually work. The second step has to be a common binomial factor. So since it is, I'm going to factor out my x minus 7 here. And by factor out, I mean it divides out. That's what factoring is. So this piece, you divide by x minus 7. What's left is the x squared in parentheses. So you write x squared. And then when I divide this by x minus 7, so I'm going to slide it to the right there so it doesn't get blocked by my submit answer button. Divide those out, and I'm left with this negative 14. Now, I double check to see if anything factors further. This is not the difference of squares, so I'm going to leave it alone. And that will be my GCF, or sorry, my factor by grouping, the GCF being a common binomial factor at the next step.